All right, hey ninth graders. Yesterday we talked about domain and range, and we talked about the x and y intercept, and we talked about continuous and discrete functions. Today we are going to write down some of that stuff as definitions so that you have it all in one place. And we are also going to talk about a couple extra things like decreasing and increasing intervals, maximums and minimums, and a little bit more practice with a couple of the things that we talked about yesterday. So let's get started with a couple of these definitions. The first definition that I want you to have, try to make this bigger screen. The first definition I want you to have is domain. So the domain of a function, as we talked about yesterday, is how far to the left or the right that the graph goes. And you're always going to use the x-axis when you're describing the domain. So you're going to look at how far to the left the graph goes, and then how far to the right, and you'll write it in an interval notation. And it might even be helpful where it says x-axis to remind you that it's an interval. I'll draw like little brackets around this x-axis. Okay, so that's the domain. The range is going to be how far, remove this picture of me, hello, how far up or down the graph goes. And for the range, you're going to be using the y-axis. It'll still be an interval, but for the range, it's going to be an interval on the y-axis. Okay, so we've got domain. Domain is left and right. Range is going to be how far up or down the graph goes. The next thing is going to be increasing intervals. So an increasing interval is wherever the graph goes upwards. And you're always going to be moving from left to right on these graphs. So think about it like a roller coaster. You start on the far left, and if the graph is going uphill toward the right, then it's going to be an increasing interval. And you describe it using the x-axis. Now a decreasing interval is wherever the graph goes downhill from left to right. And you'll use the x-axis again in interval notation. Maximum and minimum, you've seen these before, but let's get the definitions down. Maximum is the highest point on the graph. This is not going to be an interval because the highest point is one single dot. So you find that highest point on the graph and you write it as a coordinate x comma y. There are some graphs that do not have a maximum because their highest point goes on and on forever. So that would be no maximum. Same thing goes for minimums. Minimum is going to be the lowest, I know this is over here, the lowest point on the graph. It'll be written as a coordinate if it exists. But if your graph goes down forever, then there's no minimum. Okay, so the lowest point, that coordinate, will be your minimum. Okay, we'll talk about the x and the y intercepts. We discussed these a little bit yesterday, but the x-intercept is where the graph crosses the x-axis. It'll always be a number for the x value and then 0 for the y value because all x-intercepts are going to be up 0 spaces from the x-axis. Now the y-intercept will be similar, but it's going to be where the graph crosses the y-axis. And then the coordinate is going to be 0 for the x value because it doesn't go to the left or right at all. And then it has some value for the y because that's where it tells you how far up or down it is on the y-axis. Okay, yesterday we said discrete was the domain and range somewhere along there. It's broken. So it's going to be split up into different sections. And continuous, kind of the opposite of that, domain and range include all numbers. There are no breaks. This page of notes is going to be very helpful as you prepare for this next test on features of functions, which is, I think, sometime next week. I actually cannot remember for sure, but I'll talk about it more next week. So make sure that you've got this page of notes written down properly or copied and pasted or whatever you've got and need. All right, I'm gonna go and we're gonna do a couple examples on the next page. Okay, so here we've got this graph. Your job is to find INC. That's just shorthand for increasing interval, decreasing interval, and we're going to find the maximum and minimum. So I'm going to start by looking at the increasing interval. If this were a roller coaster, I start on the far left, and I'm going to go all the way in this direction. That is uphill. That means that this is an increasing interval. And then I follow downhill over here. That's going to be my decreasing interval. So I know I'm going to have one increasing interval and I'm going to have one decreasing interval. So let's start with that increasing interval. That is a solid filled in dot. I'll move my little dot there so you can see. That is a solid filled in dot that it starts at. So that means I'm going to have a hard bracket for the beginning at -3 here. So when I come over here, I'm going to have hard bracket. The furthest left that this goes, because increasing, I always use the x-axis, starts at -3. Then I come all the way, increase, 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 and then I get to this dot. And then I get a little bit, I don't know, I have to think about that for a second because it's at 1, so I know I go to the right till I get to 1, but should that be included as part of the increasing interval? It is a filled in circle, but it also is a filled in circle on the decreasing side. So that top point, you have to think about like if you were to, I don't know, like throw a ball into the air. When you throw it into the air and it gets to the top, it has to turn around and change direction. So it hovers there for like 2 seconds, not even, that's like impossible. But it like hovers there for a portion of a second and then it goes down. So it's going up, 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 and then it pauses and then comes down, down, down. So we have to think about this top point as a pause. It's not going to be included in the increase or the decrease. So I'm going to do an open parenthesis there because technically right here at 1, that's not included as part of my uphill. Okay, so let's look at the downhill now for the decreasing interval. On that decreasing interval, let's change this to green. Wait, that's not what I want this one. Let's change this to green. Okay, so on my decreasing interval, again, it starts here, but remember that's that top special point where it's not technically going uphill or downhill up here. So I'm going to start by saying open circle at 1. And I'll get rid of this guy. Okay, we got our open circle now at 1, and then it stops over here at 4. Because it goes to the right 4 spaces. And it actually does include that 4 because that 4 is the ending point, and there's no other like change in direction after that. And it looks like it's filled in. It's kind of hard to tell. Let's just call it filled in there. Okay, so that's our increasing and decreasing intervals. Our maximum is going to be the highest point on the graph. That is this dot up here. So how do I get to that dot? Well, I start at the origin. I go to the right 1, up 4. Bam, there's my ordered pair. That is not an interval. It is a coordinate, 1, 4. The only reason I know it's a coordinate, yeah, it looks like an interval, but I know it's a coordinate because it says maximum there, and maximums have to be a coordinate. Okay, so minimum, I have to find the lowest point on this graph. So the lowest point on this graph is right here. That's to the right 4 spaces, up 0. So I'd say 4, 0. Those are our 4 answers for this first example. Let's look at another example to get you some more practice. Okay, on this picture, we've got an increasing interval, decreasing interval, maximum, and minimum. Let's talk about increasing first. If this were, well, this would be a really scary roller coaster because it is discrete. You're going uphill, and then you jump, start going downhill, jump, start going uphill, and then start going downhill. So this is not continuous, it is discrete, but we still have uphill and downhill sections. So we still have increasing and decreasing. I'm going to highlight all of my increasing intervals in purple. So this one right here is an increasing interval, and this one right here is an increasing interval. If you're wondering why we can't increase backwards, it's because you cannot increase backwards. You can only do these going from left to right like a roller coaster. You're always going in this direction. Okay, so those increasing intervals, let's write them in as an ordered pair. That's a filled in circle. So I know it has to start here at -6, and then it goes to the right. And this one is included because it's not a turning point. It doesn't go downhill right after this dot. So technically that dot is a part of the increase because that whole section, all of it is increasing. So I would say from -6 to -3. And let's see, the second section starts at 1 and it goes all the way to here, which is 1, 2, 3. So I go from 1 2, 3. Hard brackets on both of those. And I can just write the and symbol. Oh, that's supposed to be an and symbol in between. Looks not properly written. So let's just leave it without that. I can put a comma in between them as well, and that's fine. Okay, so both of those are our increasing intervals. Let's talk about the decreasing intervals now. If I do those in green, I've got my first decreasing interval here and my second decreasing interval right here. So let's talk about the first one. It begins at -2 and ends at 0. So I would say from -2 to 0. And the second decreasing interval begins at 4 and ends at 6. So I'm going to write both of those down from -2 to 0 and 4 to 6. Okay, maximum. There's a lot of crap drawn on here. I'm going to get rid of all of this stuff, and let's talk about the highest point on the graph. So the highest point on this graph is right here. So that's not an interval, that's an ordered pair. How do you get there? Well, you go to the right 3, up 4. Bam, 3, 4. Okay, the minimum, that's going to be the lowest point on the graph. Right over here. To the right 6, down 2. So 6, -2. Simple, simple, simple. Highest point, lowest point. Okay, let's look at another example. This one's curved. It seems kind of difficult, but I promise it's not going to be. So let's talk about increasing. We are going to draw in our pictures from before. So this thing, do you see how it like goes uphill, uphill, uphill? Then it's like unknown zone up here, and then downhill, 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 uphill, uphill, uphill. So let's draw those places where it changes. So I'm going to say like right here looks like a place where it changes from uphill to downhill. And then I don't think it's quite at 5. I also don't think it's quite at 6. I'm going to call it halfway between those. That's our other like change point. So between those change points, we have a downhill, and then we have uphills around it. So I'm going to say uphill is over here, like that. And then another uphill over here. And then we've got a downhill or decreasing right here. Okay, so this first increasing section, where does it start increasing? It looks like this is -5, so -6, -7, -8. That's where it begins with a filled in circle. But then when we get to this 0 over here, that spot is not technically increasing or decreasing. That's where that like ball that you throw in the air pauses for just a millisecond at the top before it goes back down. So this dot up here is an open circle of uphill or downhill. So I'm going to say that it doesn't actually include 0. Okay, so there's my first increasing interval. My second increasing interval starts here, but again, this bottom dot is not increasing or decreasing. So I have to do an open circle because that's like an unknown zone. That's where it's changing from downhill to uphill. And then it can finish its uphill increasing over here at 10. Okay, so we've got from -8 to 0, and then from 5.5 to 10. Those are our 2 increasing intervals. And you'll notice there was a hard bracket at -8 because that's a filled in circle, and a soft bracket at 0 because that was a turning point. Not an uphill point, not a downhill point, it was a turning point. Okay, then our second section begins at 5.5 with the open circle because 5.5 was a turning point. And it goes to the right all the way to 10 with a filled in circle. So that means it was a closed bracket. Okay, now let's talk about that green decreasing section. I'm gonna get rid of these 3 blue dots or blue bracket things. Okay, so for the decreasing interval, we have the 0 spot, remember, where it's not increasing or decreasing, and the 5.5 spot. This one's gonna look weird. 0, 5.5 with parentheses. That looks like an ordered pair. Ms. Johnson, how can I tell that that is an interval and not an ordered pair? Well, there's only one way you can tell. Because I said decreasing. Because it says decreasing there, you know that this is talking about from 0 to 5.5. Because when you go and look at the maximum in just a second, it's going to be an ordered pair, and it's going to be written with parentheses because there's not a ton of symbols in mathematics, and they just have to steal from each other. And I'm really sorry that that happens in life. I wish I could change that for you, but I can't. Okay, so let's talk about the maximum. Here's my favorite mistake that people make on this maximum. I always see people who say, Miss Johnson, bam, that's the maximum, highest point on the whole graph. It's not the maximum, ninth graders. That's not the highest point on the graph. That's only up like 4.25. There is a higher dot than this. Over here. This dot is the highest point on the graph. It goes up 5 spaces. That's much more. So that maximum is to the right 10 spaces, up 5. 10, 5. Now, how do we know that that is an that is an ordered pair and not an interval? Well, because it's asking for a maximum. And if you remember back to the first page of notes, hold on, this is gonna, right here, it said that a maximum is a coordinate. So whenever you're looking at a maximum, it's going to be a coordinate rather than an interval. Okay, so we were here. We had just talked about the maximum. Now let's talk about the minimum. Our minimum dot, lowest dot on the whole graph, is over here. That is -8 down 3. So I'm going to say -8, -3 as an ordered pair because I know a minimum is an ordered pair / coordinate. Okay, I think there's one more slide. Let's check it out. Okay, this one. You're gonna look at this. I want you to push pause for a second and try to get these 4 questions. Welcome back. Okay, so where is this graph increasing? If I start at the left, is there anywhere on this graph that goes uphill? No, there's not. There's no increasing section, none. Sometimes in math we use a symbol. I think the symbol is technically called like the empty set, but it's a circle, oh boy, with a dash through it. If you want to say none in math, that's one way to do it. Okay, decreasing. Where is this graph going downhill? I hope that you're thinking everywhere. Yeah, but there's a mathematical way to write the interval of everywhere. So how far to the left does this thing go downhill? Well, it starts -infinity. And then it keeps going downhill to the right forever to +infinity. So the decreasing interval everywhere, -infinity to +infinity. That means forever in the left direction and forever in the right direction, it's going to be going downhill. Okay, highest point on this graph. That arrow, this thing right here, is not technically the highest point. We can't say -6, 7, 8, 9 up 4 because that arrow means it goes on forever. So if it goes on forever, you might be tempted to say the maximum is infinity, but that's not a maximum. Infinity is not a number, it's an idea. So if you're trying to find the highest dot, you can always find one that's higher than whatever dot you find. That means that we say none. There is no maximum because you can always just keep going higher and higher and higher. Well, if that's the case, and this arrow also has, or this graph also has an arrow going downhill, what does that mean about the minimum? Well, there is none. There's no minimum, no maximum here because it can always go up higher or down lower. So this should give you enough practice to try today's problems. They're similar to yesterday. They might even look like the same exact graphs from yesterday because they are the same graphs from yesterday, but they are new questions asking about increasing and decreasing, max and min, and intercepts. So give that a try and let me or Mr. Bodley know if you're still having trouble. All right, we'll talk to you later, ninth graders.